Now let us get a deeper understanding of similar triangles. Consider two triangles or two similar triangles. Triangle ABC and triangle PQR. Vertices ABC correspond to vertices PQR. Okay, these two triangles are similar, but what else do similar triangles convey? What do they tell us about these about the sides and angles? Well, quite a lot, I would say. First, let us look at the sides. Similar triangles always have the corresponding sides in proportion. In these two triangles, based on the correspondence, side AB corresponds to side PQ. Similarly, side BC corresponds to side QR, and side CA corresponds to side RP. Corresponding sides in proportion means the ratio of all three pairs of corresponding sides will be equal. The ratio of AB to PQ will equal the ratio of BC to QR will equal the ratio of CA to RP. AB and PQ are corresponding sides. BC and QR are corresponding sides. And CA and RP are also corresponding sides. But what does this actually mean? It means that each side is scaled up or scaled down by the same factor, which we called it before scale factor of enlargement. Here, factor with which AB is increased to get PQ is the same as the factor with which BC is increased to get QR, or as the factor with which CA is increased to get RP. So remember, when the triangles are similar, the corresponding sides will always be in a proportion. Now let us get to the angles. Similar triangles also always have the same shape. What does that tell us about the angles? Yes, the measures of the corresponding angles of similar triangles will be equal based on the corresponding vertices. Angle A corresponds to angle P, angle B corresponds to angle Q, and angle C corresponds to angle R. So, angle A will be congruent or same measures to angle P. This can be also written as measure of angle A equal measure of angle B. It means if we take a protractor and measure these two angles, they will be equal. Similarly, angle B will be congruent to angle Q, and angle C is congruent to angle R. When the triangles are similar, the corresponding angles will be equal. We can deduce all this when we are given that the two triangles are similar. For the two similar triangles, the corresponding sides in a proportion and the corresponding angles are equal. Here we were given that triangle ABC is similar to triangle PQR. Is similar to can be replaced is similar to here. It can be replaced with the sign, the sign of the similarity. So this can be read as triangle ABC is similar to triangle PQR. Actually, it also works the other way around. If we were given either of these conditions, we can see that the triangles are similar. Remember, either of the conditions. So, if we were told that all pairs of the corresponding sides are in proportion, we can be sure that the two triangles are similar. Or even if we were told that the corresponding angles are equal, we can be sure that the triangles are similar.